Good afternoon, everyone. It is a privilege that today we have with us Dr. Perminder Kaur from DST Center for Policy Research, which is housed at Indian Institute of Sciences, Bangalore. I would like to welcome Dr. Perminder and thank you, Dr. Saab, for joining us for this very important session on paradigm shift in energy sector through green hydrogen. I would like to, dear participants, I would like to introduce Dr. Perminder. Dr. Perminder Jeet Kaur is a chemical engineer with doctorate in rural development technologies from IIT Delhi. Her research on biomass treatment and characterization was awarded with Professor Meera Madam Best PhD Thesis Award from IIT Delhi. Earlier, her experience as an assistant professor at University of Chemical Technology, Guru Gobind Singh Indraprastha University, New Delhi, has been there, and which has helped her to go deeper into the policy and green energy technologies. As a project scientist in the Government of India's Unnat Bharat Abhiyan, she has also worked on the village development plans. She has been a mentor of change program of Niti Aayog, and which has given her a platform to inculcate scientific temper among school children. Presently, Dr. Kaur is working as a senior policy fellow at the Department of Science and Technology for policy research at IISc Bangalore. And Dr. Perminder is working on investigations of policy level interventions which are required for the bioenergy and green hydrogen in the country. Dr. Perminder has also authored a book on sustainable technologies for waste management, and she has published various book chapters and research papers in referred journals of repute. Dr. Perminder is very passionate about decentralized solutions for multi-sectoral environmental, climate change, and renewable energy policy issues. So welcome, Dr. Perminder. It is an honor for Skill Council for Green Jobs to have you as a speaker on 75 series of Azadi Ka Amrit Mahotsav. And we would now request you to kindly take the session further. Now I would like to hand over the entire session to you. Thank you, Dr. Perminder.
Thank you, Dr. Apit, for your kind words, and thank you for Skill Council of India for initiating this webinar series. This is, I think, the need of the hour, because there are so many new and emerging technologies, and we need people who have those capacities to carry forward those lab-based technologies, those to develop the entrepreneurship programs, as well as manpower to carry out this work further. So I'll start my talk by sharing my screen. So I hope my screen is visible.
Yes, ma'am, it is visible.
So the topic of my talk today is about paradigm shift in renewable energy sector, basically through green hydrogen. What are the major strengths of this sector, and where are the gaps existing, so that future work can be carried out in those directions. So a broad, the content of my presentation will be a brief introduction to hydrogen as a fuel. Then what are the pathways by which we can achieve renewable energy through green hydrogen? It's detailed discussion. Then global and Indian sector scenario, challenges, and what are the various gaps? And then what are the recommendations for future work and way forward? So as we all know that right now our environment is undergoing many changes. There are so many concerns about the changing sudden weather conditions, sudden heatland islands develop in the cities, and majority of these climate change related issues are because of various energy sources which are fossil fuel based. Along with this, nowadays we have a like awareness about the environment friendly technologies, and we are giving a preference to environment friendly technologies looking at the scenario nowadays. Along with this, there is renewable energies nowadays continuously, the prices are continuously decreasing, like solar, wind energy. They're widely available. They are spreading across the country. So a combination of this has triggered a new trend in both government as well as industrial sector. Looking at these climate change effects, there's severe changes which are happening around us. Around 196 countries had signed the Paris Agreement in 2016. which has set the goal of limiting global warming to below 2 degrees Celsius of pre-industrial level, as well as we have to reduce the temperature to 1.5 degrees Celsius so that we can contain those environment changes. So how we can achieve this? For a path, there is a need to devise a pathway to achieve those global goals which all countries have set. So this transition requires a change in the energy system. Where we were earlier using fossil fuel based energy systems, there is a need to move towards environment friendly energy sources like hydrogen, which is totally non-carbon based source. This has led to discussions related to development of a green hydrogen-based economy. There are various individual players like hydrogen consumer, producer, plant operators, manufacturers. So it requires a combined effect of combined efforts of all these players to achieve a paradigm shift in the renewable energy sector. So first of all, why we are discussing this? Why hydrogen? Because first of all, it is a non-carbon based fuel. So being a totally non-carbon based fuel, it doesn't emit any carbon monoxide or carbon dioxide, so totally environment friendly. That of any fossil fuel. It doesn't emit any bad smell. It doesn't have any back odor. There is no color. It's totally non-polluting and clean source of energy. So it can be used both in the gaseous as well as liquid form. Hydrogen thus shows a clear potential to replace other fossil fuels in energy sector. And it finds application in various technologies. So that is why right now we call hydrogen as an ultimate fuel of 21st century. So what are the pathways, how we can achieve, how we can lead to a transition in energy sector? Because presently we are totally dependent on fossil fuel. So randomly we can't develop a non-fossil fuel based energy sector. So there has to be a pathway to achieve the transition in this energy sector from fossil fuel based economy to environment friendly technologies. So as it can be, as you can see here, it requires a consistent effort. The process is totally multidisciplinary and it requires the effort from a large number of sectors, from the upstream production, like upstream processes like production of hydrogen, to its midstream processes like storage and transport, to further downstream processes like its application in fuel industries as a chemical, for manufacture of ammonia, or for refinery, for various sectors. So we need a detailed discussion on all the four aspects of hydrogen, that is production, storage, transportation, and application. So when we talk about hydrogen production, hydrogen is already existing evidently, and it is used from a very large time by a human being. And it is a major component in various industries like ammonia production, steel production, refineries. It is one of a very important component in all these industries. So traditionally, hydrogen can be produced through natural gas, which can undergo steam methane reforming, where natural gas with methane as their major component can react with steam to produce water gas, which can further lead to water gas shift reaction to produce hydrogen. And this type of hydrogen, which we produce through natural gas, is known as gray hydrogen. Depending on the source of hydrogen from which we are producing it, different codes are given. Although hydrogen is same, it's just the color code which is given to hydrogen so that we can identify its value chain. We can identify how green that hydrogen is. So then in case we use coal or any other fossil fuel, which can undergo a gasification process in a gasifier, it can react in a gasifier to produce brown hydrogen. Then in both using natural gas as well as coal, if we capture carbon, we make it environment friendly, then that leads to production of blue hydrogen. Further, in case we are using the electricity directly from grid, the presently electricity which we are using at home, so general electricity which we directly obtain from grid can undergo electrolysis process to produce natural hydrogen. So these are the various codes of hydrogen: gray hydrogen, blue hydrogen, brown and natural hydrogen. based on the source from which we manufacture it. So hydrogen nowadays is the sector is undergoing various changes nowadays. Like this graph on the right hand side shows the development of technology in the hydrogen. So these gray ones, which I'll show right now, they will be which we are using right now. And the bottom ones, which are orange and blue, they are the future in which lot of research and development is required so that we can produce green hydrogen. So coal and natural gas, then various kind of byproducts from refineries, biomass, as well as solar and wind energy. All these sources can undergo various conversion processes to produce hydrogen. When we use coal or natural gas on conversion through carbon capture technology or through bioproduct of various processes, or even biomass, which can undergo conversion technologies to produce biogas and bioethanol, which can further be converted into green hydrogen. In the future of the technology, that is green hydrogen, that lies in the use of solar and wind energy to run an electrolyzer, which is a totally green process in which we are using solar and wind energy. We are using it to run an electrolyzer, and using this process, we are producing green hydrogen. So this is the major impetus or major research work or major the field where the lot of research is undergoing to produce green hydrogen. So as we say the present status right now, majority of hydrogen is produced through steam-based steam methane reforming. Then oil reforming or coal gasification is also used to produce hydrogen. While the production through environment-friendly technologies or renewable energy to run an electrolyzer, it right now has a very minor share in the total hydrogen which is available in the market. So before talking in detail about the various kind of electrolyzers which can be used to produce hydrogen. So electrolyzer, as we know, is a basic process which we have read in class 9th or 10th also. So in an electrolyzer, we use water, which is H2O, which is basically hydrogen and oxygen. It can undergo a process of electrolysis through electricity. We can break down water H2O into hydrogen as well as oxygen gas. So at cathode, hydrogen ions react with electrons to produce hydrogen gas, while at anode we get oxygen gas. So depending on the kind of the electrolytic solution we are using, kind of the electrodes we are using, reaction conditions we are operating it on, electrolyzers can be further divided into various categories, which can be solid oxide electrolyzers or polymer-based electrolyzers, or known as PEM, or alkaline electrolyzers. The process of electrolysis has also undergone tremendous changes over a period of time. Electrolyzers were initially developed in 1800 century, and initially they were basically used for the production of they were developed through diaphragms, and industrially they were basically alkaline water electrolyzers they were developed, and there were a lot of challenges regarding to their industrial scale application during that time. Further, lot of changes have happened in the process. Various technological breakthroughs has happened over a period of time from 1950 to 2020 basically. So during these years, electrolyzer technology has gone various changes from alkaline based electrolyzers to polymer based electrolyzers, and now solid state electrolyzers. When in 1950s polymers were developed, the technological breakthrough has happened in the process of this electrolysis technology. Then polymers were discovered. They were basically used for the life support applications. So during 1950s to 1980s, electrolyzers which were based on the polymer were discovered. Then there further with the further breakthrough in the technology over the complex system, there is the development of the PEM water electrolyzers, but still there were challenges related to its cost. Further, during the decade of 2010 to 2020, lot of changes in the electrolyzer capacities has happened, and large-scale demonstration of polymer-based electrolyzers were lot of changes have happened in this stream. And nowadays, from like the present time, which is known as the 5th generation of electrolyzers, the work is going on the cost, efficiency, as well as durability of electrolyzers with the technological breakthrough in the development of various novel metals. And we are in a process to develop electrolyzers which were in the first generation of electrolyzers. So they use a liquid electrolyte solution like sodium hydroxide or sodium potassium hydroxide and water, which can undergo electrolysis process. A diaphragm was used in this process, and it can split into hydronium ions, which can further produce hydrogen at the cathode and oxygen at the anode. So there are various advantages of this technology because it's a old technology. This is not something new. We are using it since 1800th century. So it's well established. It is available on a commercial scale. Various noble metals which can be used as free electrocatalysts, they are available. Their cost is low. They have a long-term stability, but their efficiency is around 50 to 70%, and their cost is around 270 US dollars for 1 megawatt capacity. However, availability of electrolyte, high concentration potassium hydroxide solution is required. So a lot of changes has happened from movement of alkaline electrolyzers to proton exchange membrane electrolyzers, where a membrane is used instead of a diaphragm. Here, as we can see in the diagram, we have a membrane instead of a diaphragm, and this is a very compact system where the hydrogen gas is evolved here on the cathode and oxygen gas is evolved over here. So basic process is same. It's just the change of the system from diaphragm to membrane and development of novel materials, which has led to development of PEM electrolyzers. So nowadays it is also commercialized technology. It also operates on high current density. We get the gases of very high purity. The system, like in alkaline electrolyzers, which were bulky, the system is compact here. Efficiency is relatively better from 70 to 83%, and cost is relatively higher, which is around $100. So there are electrolytes, which can further help to reduce the cost of PEM electrolyzers. Further, solid oxide electrolyzers, which operate on a high temperature, they are the material of future on which the various researchers are right now working to develop them and transport this technology to commercial scale to improve their technology readiness level. So solid oxide electrolyzers is also known as, sorry, is there any, I'm audible?
You're audible, ma'am. Please go ahead.
Solid oxide electrolyzers operate at very high temperature, between 500 to 850 degrees Celsius. So the use of high temperature overall helps in the breakdown of water more easily, and this leads to a higher efficiency in solid oxide electrolyzers. And then there are various advantages, like they work at high temperature, so they are highly efficient to break down the water easily. Their efficiency is very high. Their cost is right now very high, although. So there is need to work on the development of their more stability and their lab scale to conversion to commercial scale. The work is still underway. Various companies, various research groups, they are working to commercialize this technology. So there are other type of electrolyzers also, which are not as efficient and as cost effective as we have discussed above, but they have a lot of potential for development. One of the examples is photoelectrolyzers. So these, as the name suggests, photoelectrolyzers, they use sunlight to separate water molecules without need of any electricity. So as we will not need any electricity, so this is going to be a revolutionary material. So many of these technologies are still under the stage of development. Lot of research is happening every day in the field of electrolyzers, which is the heart of green hydrogen production technology. So what are the various components which are required for manufacture of an electrolyzer? To run an electrolyzer, basically the running components which are required are basically a continuous supply of renewable energy, availability of a continuous supply of renewable energy, either solar energy or wind energy, along with the availability of water resources, which can undergo electrolysis in an alkaline or PEM electrolyzer. So basically a PEM electrolyzer, the cost falls under the two components. One is the stack, which costs around 50% for alkaline electrolyzers. Stack cost is very high in case of PEM electrolyzers, and stack cost is around 30% of the total cost in a solid oxide electrolyzer. The balance of the system includes, we will need a power electronic system, we will need gas purification system, and we will need water purification system. So rest of the cost, one component is stack and other component is power electronics, gas purification system, and water purification system. So in order to install electrolyzer, we need all these components. While the stack and electrolyzer will be the fixed cost, running cost will include the continuous supply of renewable energy and water. So, as per various studies have been undertaken in research to estimate, to evaluate the cost of hydrogen produced through various sources. And it has been found that when we use direct electricity to produce hydrogen, the cost is between 200 to 400 rupees per kg. For off-grid, in case we use solar energy, the cost is between 100 to 200. Then for natural gas, cost is around 100 to 170, 180. And for coal, the cost is around, falls between 200 to 200 rupees per kg. So all these technologies are right now expensive. So government is providing through National Hydrogen Mission, is providing the incentives, providing the support, capacity building to reduce the overall cost of production of hydrogen produced through solar energy or other renewable energy sources. A breakdown of levelized cost of hydrogen from electrolyzer route has been studied by another report, and it has been found that in case like right now the cost of alkaline electrolyzer, their levelized cost is around more 350 rupees per kg, but by 2050 it should fall to 200 rupees per kg. For alkaline electrolyzers by 2050, the cost should be less than 100 rupees per kg, and for PM electrolyzer also through the solar process, the cost should be less than 100 rupees per kg. So once the hydrogen is produced at large scale, it is available at large scale, then only we can investigate its application for various purposes. So this is a vicious circle. The one is that we need more hydrogen to develop its more applications. Applications will be developed only if we have large scale availability of hydrogen. And hydrogen, we will produce more hydrogen only if they have a demand. So both things should go hand in hand. The second important component of hydrogen economy is its storage. So various materials have been developed, various physical systems have been developed, because storage is the main system which will provide a linkage between the hydrogen producer and hydrogen consumer. So an efficient energy storage system can only boost an efficient hydrogen economy. We need an excellent, cost-effective, intermittent energy storage system which needs extensive research. So right now there are basically two kinds of materials which are used for the storage. One is the physical system, which includes systems like compressed gas or cryocompressors or liquid systems. Then various novel materials have been investigated, have been studied to store hydrogen. Various kind of adsorbents which can be carbon based, or various kind of chemicals which can be organic as well as inorganic, or hydride materials which can be interstitial or complex, have been developed to store hydrogen under different conditions. The third important component of hydrogen economy is its transportation. Once we have produced hydrogen, we have stored it under the right conditions, then we need to transport it to the applications where it is going to be used. So there are a variety of hydrogen transportation systems which have been proposed. The most common hydrogen transportation method is compressed gas cylinders or cryogenic liquid cylinders or pipelines, or we can blend it with natural gas, and we can transmit it through the same pipelines through which natural gas is transferred. Then there are various compressed gas containers, we have pipelines. We can also blend them with natural gas. So blending with natural gas pipeline network is viewed as transporting pure hydrogen to market. So all these technologies are under a stage of development. So basically, when we, broadly speaking, the hydrogen transportation system comes under two categories, either through the hydrogen pipelines or hydrogen mixed with CNG pipelines or tube trailers, which comes under compressed gaseous transport system. Hydrogen can also be converted into liquid form, and it can be stored under the liquid cryogenic systems or LOHC systems. Then comes another important aspect of hydrogen-based economy, which is application of hydrogen. Application of hydrogen is not something new. Hydrogen is already used for multiple industrial processes. Hydrogen in Haber process for the production of ammonia is a very well-known technology. So it can be used as a feedstock for various chemicals in the fertilizer industry, in fuel refining, in production of plastic. It can be used to produce metallurgical glass, steel, or food. So various kind of chemicals can be produced through hydrogen. Then it can be used as a heat source for various industries like steel or cement-based industries, which are known to be a very energy consuming sector, steel as well as cement. So the use of hydrogen instead of fossil fuel in steel or cement industry can give a boost to environment-friendly technology and control the emission of greenhouse gases. Then various industries like paper industry, food, or aluminium industry. It can also be used for heating residential and commercial setups. Then one of the emerging areas where hydrogen can be used is in the transport sector. Nowadays, you must have read the headlines of various newspapers, like Germany has launched hydrogen train, or India is launched, in Delhi we have launched hydrogen gas buses. Government is working on hydrogen based train system, then in shipping sector. So the development of hydrogen as a fuel in transport system is one of the future areas where hydrogen can be used in trucks, in aeroplanes, in shippings, automobiles, or as a synthetic fuel. Then various electric peaking plants, they can also use hydrogen as a source of power. Now, what is the significance of hydrogen for the market? It has been various reports, various studies have been undertaken by various research institutes, as well as various think tanks, various organizations. Everyone is trying to investigate the effect of hydrogen on the market. And it has been found that this is a really exciting time for the market. With a large number of hydrogen-based companies, they are in a stage of launching, or they're already launched, and many of them have been listed in the stock exchange in the past 12 months. Market has seen a large change. Then global hydrogen market has been evaluated to be around 0.83 billion US dollars. It was in year 2021. And it has been various projections, various expectations are there from the hydrogen sector. And it has been found that the hydrogen-based market can increase to around $90 by 2030. So for early investors, there is a lot of scope. They have a lot to watch. For an investment perspective, it is highly encouraging to see government backing in emerging market, as it drives interest and reassure investors in viability. Government is a big investor nowadays itself. Government is trying to support the development of various kind of technologies, various incentive schemes, various tax breaks and mandates are under a stage of development. So with this rapid development of technology, these research initiatives, large-scale adoption is expected within a few years. Now, in the global scale also, various countries have announced their commitment for hydrogen as a part of their strategy to contain their climate emissions, their greenhouse gas reductions, and meet their net zero targets. Like in United States, European Union, they have given a target to reach net zero by 2050, while India has a net zero target of 2070. So we can't reach there in a day. We have to move in a step-by-step manner through the use of these environment-friendly technologies. Each country's strategy differs, but the key focus is same: to develop an economy which is environment-friendly. Some countries like European Union, they are focusing on majorly on carbon capture, while some countries like India is working on the development of green hydrogen technology because we have large scale availability of solar energy as well as wind energy. So around these are the list of the countries which have launched their hydrogen strategy in past few years. Looking at the Indian scenario, National Hydrogen Mission has been launched by the Government of India. Recently, some guidelines have been launched again in January 23. So it has been, government is providing support to various organizations so that India can become a global health hub for the production, usage and export of green hydrogen and its derivatives. So this will contribute to India's aim to become Atmanirbhar Bharat. Mission will support the replacement of fossil fuel or fossil fuel based feedstocks with the renewable energy sources like green hydrogen. So there the research work as well as the applications of hydrogen in the usage of hydrogen, in the production of hydrogen in these sectors will be encouraged. So expected outcome of this mission by 2030 includes annual production capacity of 5 million metric tons per annum, renewable energy capacity with addition of around 125 gigawatt with over investment of around rupees 8 lakh crore. With it has been expected that this lead to creation of around 6 lakh full-time jobs and 50 million metric tons of CO2 emission will be curtailed. So these data we have taken from the website of Ministry of New and Renewable Energy. Now, to achieve these targets, because we have certain big ambitious plans. So to achieve these targets, the government and as well as the research institute, industries, we need a planned strategy. We need various inputs. So how can we achieve this? This can be achieved through combining all these sectors. Like it has been proposed that the hydrogen production, hydrogen transportation, as well as hydrogen application. Various aspects have to be explored simultaneously. Since this is an interdisciplinary stream and production of green hydrogen, their storage, transportation, this is something new. So all these sectors have to work in sync with each other. Particularly for hydrogen production sector, the literature review suggests that green hydrogen needs continuous and low cost of renewable energy supply. So there is a need to develop indigenous efficient electrolyzers which can run on these low cost renewable energy supply continuously with high durability and high efficiency. Along with this, we have to see the efficiencies of these electrolyzers and their full leak-proof methods. There should be a minimum wastage of water in all these electrolyzers. It needs a continuous supply and availability of water. Then we need access to large-scale renewable energy sectors also. And then for the transportation sector offer various promises. So many efforts are still needed to address various safety issues like the embrittlement of material when we store hydrogen or transport hydrogen through those materials and containers, then flammability and the safety aspects, we cannot ignore them. Then we also need skilled manpower. We like during one of my stakeholder analysis, it has been found that various research institutes as well as industry, they feel this as a hindrance. They don't have the skilled manpower. So we need specific expertise and skill sets in the area of the power electronics as well as advanced materials, running and manufacture of the electrolyzers and fuel cells, hydrogen storage systems, compression and distribution, their designing, manufacturing, installation, and their safety. We also need standards. So even government is still, and as well as Indian Standard Organization, BIS, they're also working in the development of standardization. Then it needs to be their whole value chain needs a certification that everything which is used in the production of this source of hydrogen is green. That certification is very important. Also, it's a general perception that hydrogen is highly flammable. So customer has to be made aware about the methods in which it is saved, and the awareness about the safety of the hydrogen when to be used for the domestic or residential purposes. Storage system also needs various kind of support in terms of the system cost, in terms of the fuel cost, efficiency of the storage systems, then quality of the fuel, durability and their operability, then application of the hydrogen. So there is a lot of scope to work on the hydrogen storage technologies. Various technical barriers are there which need to be overcome to achieve a full potential for the hydrogen-based economy. So, as a recommendation, it has been found that even when we have spoken to various, during our stakeholder analysis, when we have spoken to various startups and various entrepreneurs, they have found that there is a kind of aversion in the financial sector also, because hydrogen application, hydrogen as a fuel is something new. So even financing hydrogen products, so there is a need to provide the support for the risk mitigation measures for the industrial players, which is very important. This can be done by providing the concessional funding, educational and building capacity for the industries, participation of public and private sector in this, and shared learning on the technology readiness level and demonstration of hydrogen projects. This is very important. Then also measures are required for special funding of the domestic pilot projects. International cooperation is also very important. Now, since India is hosting G20 this year, we have got the presidency. So this gives a lot of opportunity for green hydrogen sector, because no one country can achieve a full expertise on all the four aspects of hydrogen economy. So international collaboration and cooperation will play a very important role. Science diplomacy has a very important role here. So this has given India a unique opportunity to become global leader in hydrogen energy ecosystem. So it is hoped that with proper policy support, industrial action, market generation, acceptance, increased investor interest, India can position itself as a low-cost, zero-carbon manufacturing hub, at the same time fulfilling the goal of economic development, job creation, and improved public health. Since we need skilled manpower here in this system, so there is the need to design and develop develop the capacity as well as the skill of people around us. So this is a very good initiative. We have attended one of the webinars also, one of the training programs I have attended in the around last 2 weeks. So they have developed a similar kind of program to build the capacity skill set for the people in the field of green hydrogen. So such suitable courses and programs should be encouraged. So we hope that by through these steps, we all can achieve a sustainable development goal of clean environment, and we will be able to achieve our net zero targets in the given timeline. So success of all these schemes will depend on our capacity to innovate in the streams of hydrogen production, storage, transportation, and its application in various sectors. Thank you. So we can take some question answers now.
Yes, ma'am. Yeah, Ram.
So do you want to drive it, sir?
No. Okay. Some questions are available on the chat box.
I'll pick the question, sir.
Okay.
Ma'am, the first question is from Dr. S.N. Srinivas. He's asking, are there fully functional green hydrogen generating units in India? Where are they? I believe one of the participants have answered that. If it is a different answer, you can probably give a different answer. But her answer to it was just a second. Oh, so okay. So Kavya Mohan replied, there is one fully functional green hydrogen plant at L&T steel making facility in Hazira. Would you be able to share details of it, performance and utilization? So yeah, if there is any different answer, ma'am, you can probably attempt it.
Actually, this is one of the most relevant question, because once we have some success stories before us, then only we can take it as a motivation for others to follow it. So various initiatives like in Assam, Jorhat, there is one plant which was announced by the government of India. So those plants are running successfully. Various industries are coming forward, and along with this, the Hydrogen Valley platform, where the hub for hydrogen sector is under the stage of development. So many plants have been, like in last 1 year only itself, many new plants have been announced, and they are under the stage of development right now.
Okay, thank you, ma'am. The next question is from Dr. P. Raman. In one of the slide, a biomass to green hydrogen is proposed by biogas and bioethanol. Biomass steam gasification for hydrogen production is also an efficient process. Any specific reason for which it is not included?
Yeah, because I had limited time. We know that biomass, conversion of biomass to green hydrogen is also supposed to be one of the environment-friendly technologies, and many researchers are still working on the development of lab-scale technologies. So yes, that is true. We can count that also, but since I had limited time, so that is why I could not cover everything here. So I focus more on electrolysis of water. So maybe in future technologies we can talk about that also.
Thank you, ma'am. There's the third question. There's a lot of focus on electrolyzer as a technology for green hydrogen. However, there is not much work that is happening on biogas, bio-CNG to green hydrogen. Is there a specific reason for this? This comes from Swati.
Yeah, Swati, because it's an energy intensive process to produce when we are using those pyrolyzers or gasification units for conversion while we're using thermal processes. So firstly, that in energy intensive process, then there are various challenges with biomass, like their availability. They are not, those bio-waste, they are not available throughout the year. Then the major challenge which biomass producer face is that their quality is not consistent. So it's very difficult to standardize those technologies. So both water as well as biomass, both technologies are under the stage of development, but majorly water is used because it's very easier to standardize an electrolyzer rather than biomass based processes. So even many industries, they face for biofuel also, they face it a problem about the availability of biomass and their quality. Then it needs a lot of pre-treatment processes also before you use it for the energy purpose. So that is why more impetus is given to water-based electrolysis processes.
Mr. Ram, can you give permission to MR Noni, sir, if he wants to speak something?
Sure. Can you please repeat the name, sir? Display name. What is
MR
the
Noni.
MR? Okay, just have.
MR.
Okay, got it. I'm just giving him the permission.
Noni, sir, you want to say something?
Sure. He has the speaking rights.
Anyway, hello.
Sure, sir. So we can move to the last question, which is the fourth one. Okay, ma'am, this is the last question. Is there any okay, so there are two questions, I'm sorry. Do we have available technology for safely using hydrogen in the automobile segment? If possible, can you elaborate on this?
For automobile sector, like for EV also, when we are using the fuel cell, so that fuel cell can work on the basis of hydrogen. So many companies every day in newspapers, you can even yesterday only I was seeing the headlines. One of the automakers, they have announced that they are launching their EV, which will be based on hydrogen. So many automakers are coming forward to use hydrogen in the fuel cell for EVs also. Various hydrogen buses, hydrogen based trains, they are already in the like they have already been launched in Germany, as well as India is also planning to launch hydrogen, because in green hydrogen mission also the Ministry of Roads and Transport as well as Ministry of Railways, they are an important stakeholder in the new hydrogen mission, where the use of green hydrogen in the transport sector will be evaluated and will be encouraged.
Thank you, ma'am. The last question was from Lokesh Kumar. Thank you, Lokesh, for the question. Ma'am, this would be the last question from Priyank. Is there any future for an ion exchange membrane electrolyzer in India? 100 kW installed Indian oil, Johrat by Inapter. So you can elaborate on that.
Yes, sure, because anion bin exchangers are highly efficient. So that is why they were installed and launched by Indian Oil Company. But for like their availability for small scale startups and entrepreneurs, so there is a lot of work need to be done when we can use them for the like startups and other industries also. So researchers are working on reducing the cost of these kind of new technologies and new membrane-based electrolyzers. Their cost is one of the major hindrance.
Ma'am, would it be fine if we can take another question?
Yeah, sure.
Okay.
We have some time in hand.
This question comes from Ramesh Satla. Can we integrate the technology of using the natural heat, geothermal, in the process of producing green hydrogen?
Yes, there is a need to like explore all these innovative technologies. So even nuclear energy has been explored to use for the for heating the nuclear these water electrolyzers. So what when come to geothermal, so it's one of the very like environment friendly technology. So but lot of research work has to be done. First of all, we have to work in the lab scales, then the conversion to that technology to different like commercialization scale. That will take a lot of time, because right now, like as per my understanding, work done on this in lab scale is limited.
Thank you, ma'am. Thank you for your response. There is no other question at the moment. Singh, sir?
MR Noni sir written on the chat box. 1 minute. Renewable energy based hydrogen can be produced through oxy steam, gasification of biomass, and also through biological route by using industrial influence and other waste. Cost of alkyne and PEM based electrolyzer indicated seems to be highly optimistic.
So I didn't get the question.
Actually, one message from MR Noni: renewable energy based hydrogen can be produced through oxy steam, gasification of biomass, and also also through biological route by using industrial effluent and other wastes.
Right, sir.
Yeah, and cost of alkaline and PEM based electrolyzer indicated seems to be highly optimistic.
So actually, this is true that biomass can also be used for production of biogas and further for the production of green hydrogen. And I'm highly like enthusiastic about this, like working on biomass to energy sources. So, and for electrolysis of water also, this is one of the things which are under the stage of development. So when we have to develop the application of hydrogen for the large scale purposes, so we need to have large scale availability of hydrogen. So both routes can be explored. There is once we have large scale production of hydrogen through both biomass as well as water electrolysis, so then only we can explore their application, further applications. So definitely biomass to hydrogen can also be explored further, because biogas we can produce at a very low cost and then we can convert into hydrogen. But since I had limited time, so I could cover only about the water electrolysis.
Mr. Ram, can you give permission to Deepak Rai?
He has the permission, sir.
Deepak, you want to say something?
Thank you, ma'am. Thank you for your wonderful presentation. We also discussed last time as well. As you are aware, we are also implementing a few training sessions wherever we can on the entire value chain, right from production to storage to transportation, and obviously the evolving application area which you have already covered. So, ma'am, quick one remark and one question. So the remark possibly, I think Noni sir also highlighted that. So the cost of electrolyzer, both alkaline and PEM, what you indicated, and not so much SOEC, those seems to be a bit optimistic. I agree with that. Typically, so the kind of numbers what we have, again, in literature and some sources in industry, usually, yes, it's in the range, but again, depending upon the size of electrolyzer, but typically, total aggregated stack size. But nonetheless, even for a kilowatt level, on an average, the cost is around, let's say, $600 to $1,000. Obviously, for the higher you go, the better it is. But yeah, for PEM, maybe it's around 1,200. So roughly, it's around 700 to 800 on an average, one may say. But your values were slightly really optimistic, So that's the remarks point of view. Ma'am, the question is, again, on what more the government should do to address the typical risks investors communities have for the large scale projects mainly. So I understand, PLI is in the making. Any day it will be announced as part of the mission. But again, you have highlighted that government is also an investor. Yes, public sector, enterprises are already putting up a lot of capital, be it NTPC, be it the oil majors, oil and gas majors. But the central government overall, what more needs to be done to attract more and more capital? You have also indicated 8 trillion rupees is the mobilization target by 2030. But what more needs to be done? Over to you, ma'am.
Yeah, actually, the cost of electrolyzers which I have taken, they are basically for large scale applications. So that's why maybe they turn out to be less. And that was some of the estimates done by the government agencies. So maybe that depicted more positive picture. So in practical, maybe at industrial level, there is something, more of the cost is unknown. There are certain unknown costs also. So maybe for small scale, the cost may be even higher. So that's true. And for the we have done a stakeholder analysis also, and as per our analysis also, we have seen that all the startups and entrepreneurs, they found it a big hindrance that investors don't come forward. They have a lot of apprehensions. They don't know what green hydrogen is or what is biofuel. So there is a lot of need to, like, the way we are generating the capacity for trained manpower. Similarly, there need to be some awareness camps for the financial sector also, so that they can also get to know that what scope of green hydrogen is there, what is green hydrogen, why people want to have a startup in green hydrogen. So lot of awareness as well as some support to those investors that government can give them, that in case this project doesn't work, so we are there as a support. So some kind of incentive, some kind of support mechanism should be developed. So we hope that, like, for the we are going through the guidelines of recently launched National Hydrogen Mission also. So government has promised that it will provide some support to the financial sector also. So we'll wait for some more announcements in this sector.
All right. Thank you, ma'am.
Yes, thanks, sir. We don't have any questions on the chat box. We can proceed with the vote of thanks.
Uh, Any other questions from participants?
No, sir, we don't have any questions in the chat box. We can conclude the session with a vote of thanks here.
So now,
Uh,
Arpit sir is
Thank you so much, Dr. Parminder, for your session. We are extremely grateful for your time and effort you took to share your thoughts and experiences on green hydrogen with our audiences. Since we are entering into a new growth phase in the green hydrogen sector, your information that you have shared and the session that you have taken is very timely placed. And I believe that all of us can benefit immediately from the methods that you have suggested for the green hydrogen production. Parminder, I would also like to comment that your enthusiasm is contagious, and we hope to use your knowledge and information in our next sessions. Thank you again for your contribution, Dr. Parminder.
Yeah, pleasure is all mine, and congratulations for Skill Council for Green Jobs for taking up these kind of initiatives.
thank you, ma'am,
Thank you.
for accepting our invitation. And finally, I would like to thank all the participants who are present here and given his valuable times. Thank you very much to all of you. Thank you, ma'am. Thank you very much.
Okay. Thanks
Thank you
to
so much, everyone. Thank you, ma'am.
Thank you, everyone.
Okay, all right. Have a good day.